Hello, everyone. I would like to take this opportunity to let you know, like Leonard was saying, that this event will be recorded. And thank you all for coming to the LAACM SIGGRAPH's December 2020 event, AI in VFX. My name is Sunil Rampersad, chair of this chapter. The LAACM SIGGRAPH is a group dedicated to showcasing the best of, as well as innovations in the fields of computer graphics, as well as interactive techniques. Our chapter produces 10 events a year and is supported by our members, whose membership dues keeps us doing what we do and also gets them free entrance to all of our events. So please consider if you like what we do. Before I get into to thanking some of the people who help make an event like this happen, if anyone has any announcements that they would like the community to know about, please send them in the Q&A chat. I will read those out. And also, if you have any positions that your company is looking to fill, put those in as well. First of all, as I was saying, I would like to thank the volunteers that make up the executive committee, which runs the chapter, many of whom are here tonight. Kyle Carlin, the vice chair, Elizabeth Cameron, secretary, Dave Kurlander, treasurer, Sharon Eisenberg, membership, Kathleen Milnes, education chair, and Tim Everingham, volunteer coordinator. Leonard Daly is our electronic services and website person, and past chairs also lend the chapter their expertise, such as Joan Collins, who's the chair emeritus, Ed Orijo, Diane People, Fran Benjamin, and Ed Lance. Thank you to everyone who helped make these events happen. We're also always interested to hear from our members. Let us know what you like or did not like, and by doing so, you help us to create better events. And let us know if you have any ideas for topics that we should cover. The Executive Council meets every Tuesday, and actually all welcome, and we're going to be meeting next week on December 15th. So yeah, we're always looking for people who are interested in either serving in positions on the EC or as producers of events. So please feel free to contact us if you're interested in being involved, or if you would be interested in just getting to know more about this chapter. You can contact us through Facebook or through our website. My first announcement, actually, the announcement that I have for today is that in 2020, the SIGGRAPH conference is going to be back in LA. Yay! But it's going to be a mostly virtual event. Well, the other thing is you shouldn't miss the submission deadlines, which are coming up. The January deadline is for technical papers, student volunteer signups, art gallery, and art papers. And in March, the deadlines are for the Computer Animation Festival and the VR Theater. Just a second. All right. Don't see any other announcements. So on with tonight's presentations. Tonight's event is going to consist of 5 presentations, the first of which is a short introduction to AI and an intro to the main concepts, which would help in the understanding of the rest of tonight's presenters when they speak about things like machine learning, deep learning, or neural networks, etc. Just a second.
Cool. You want me to rock
and
oh.
Just a second, Alan. My mistake. I was going to introduce you, but I totally messed up. But I was just going to say that Allan McKay is who's going to be presenting that segment. He's an Emmy Award-winning visual effects supervisor. I think a lot of people here know of him because he's given a lot of talks over. He has over 2 decades of experience with studios such as Industrial Light and Magic, Pixelmondo, Cooler Studios, and he's spoken at a lot of different events in over 15 different countries, including master classes at SIGGRAPH. And in his hit podcasts, interviewed a lot of award-winning artists and directors in the creative field. He runs many online courses and mentorship programs with over 1,000 members. Take it away, Alan.
Cool. Sorry, buddy. I totally threw you off. Okay. Give me 2 seconds. And can you guys just confirm that you can see my screen? Cool. Awesome. All right. So I'm going to try in 10 minutes to explain a bit about AI. So I'm just going to dive right into this. And I just want to talk about a lot of the concepts that we're going to be discussing throughout the next hour. So AI, simply put, is the simulation of human intelligence. And that means that we give AI data, it interprets the data, and then it learns from that data and gives back predictable results. So ultimately, we can process large amounts of data faster and on a larger scale. Now, I just want to go through a bit of the history really quick. I mean, AI has been around for a long time, but in the 1950s, it was coin phrased artificial intelligence. We also had the Turing test, which I know a few of us have probably heard about. Over the next like 30, 40 years, there was more ebbs and flows. And there's a lot of predictions like AI is going to become super AI and do all these things, which never really happened. The main thing is in the 90s and 2000s, we had a lot of innovation, but also a lot of excitement around AI. And that is because we had speech recognition, we had Deep Blue, IBM's AI that took on Kasparov in the battle of human versus machine and beat him in chess. And we also had the internet become mainstream, which means that we have a lot of information being shared, a lot of people being connected, and of course, big data. Now, in 2010, that was the deep learning revolution, which meant that we established artificial neural networks. Rather than it being theoretical, this was something that became a thing that was applicable. And the main thing is that now we're in 2020, and this is where we're kind of at the birth of AI in more of an applicable sense. Before this, it's always been what could happen, and now we're actually living in it. So I think it's just a really exciting time. But the main thing is that AI was being held back because of processing and storage. So there's been a lot of technological innovations around processing, storage, internet, or big data. All of this stuff has really exploded over the past decade. So just to kind of give a broader view, this is a spaghetti mess of all the different AI algorithms, and it can get really overwhelming really quickly. But the main thing we're going to focus on is just machine learning and deep learning. We're not going to worry about robotics or natural language processing, expert systems, or anything else. Now, the other thing, and again, I'm going to talk fast because I've got to go through a lot, but the other thing is that we look at machine learning, deep learning, artificial intelligence, and we kind of wonder how they correlate together or which is what. And ultimately, they're all the same thing. Deep learning is a subset of machine learning. Machine learning is a subset of artificial intelligence. So they're all kind of all in the same category. It's just deep learning's a different petition of machine learning. So if we're going to talk about machine learning, there's a lot to do here. Basically, what machine learning is that we train artificial intelligence based on previous data. And that means that we have supervised learning, unsupervised learning, reinforced learning, labels, features, ground truth. Again, I just want to put that all out there because it's very easy to get overwhelmed in the few minutes that we've been going through this. But ultimately, what it is that we're just giving the artificial intelligence a lot of training data. And we're getting it just to give it a lot of information, but then we do a lot of hand holding to get it to understand what exactly it's looking at and how to interpret that information. So one of the funnest examples I could think of is trying to get AI to determine what's a picture of a cat and what's a picture of a dog. And ultimately, you could give like 1,000 images to the machine learning algorithm and say, okay, you figure it out. And what it would do is it would probably start to teach itself wrong because we're not really giving it any conditions. So the way that machine learning works is that we would give it a lot of features, such as training it to say, this is a dog's droopy ear. This is what a cat's eye looks like. This is what whiskers look like. We start to program in all these different kind of indicators or limiters to kind of help it understand what it's looking at. And the main thing is that through doing that, it'll get a better idea. It'll start to look for whatever we feed it to try and get a better idea of like, hey, well, does the dog have whiskers? No, it doesn't. Okay, well, it's probably a dog. But it's not always going to be correct. And if we don't course correct it, it doesn't really know whether it's right or whether it's wrong. And again, it can kind of go haywire there and start to learn incorrectly. The main thing is that through reinforced learning, we're able to tell it whether it's right or wrong. So in other words, if it guesses a cat, then we're able to say, good job. And that's where it realizes, okay, cool, well, that was a cat. And when it guesses a dog and it was actually a cat, we get to say, bad job, go back, and that was a cat, so try again. The more that it's able to learn where it's right and wrong, the more it's able to get accurate with the information it's predicting. And that's the key thing, is that after a certain threshold, once we're getting the accuracy to, let's say, 80%, we could just let it go and give it more and more information, and it's able to learn on its own. It's able to get more and more accurate. So the key thing is that once it's accurate enough, we can give it more data, it learns on its own. And when we talk about like advantages or disadvantages, I think the main thing is that with machine learning, the disadvantage is that we have to program all these features. And it means that we also have to do a lot of hand holding as well. So it's learning, but it's learning from what we tell it to look for. And this means that maybe we're not giving it the right information, maybe we're sloppy, or we're giving it stuff that we think is right, but it's actually throwing it off. And at the same time, like, there's a lot of subtle things that artificial intelligence could look for to help it learn that maybe we're excluding. We're going through and excluding certain bits of information to make it really clear what to look for. And because of that, it mightn't have made as greater kind of predictions as to what it could do if it was able to look at all the data. So that's the difference here, is like when we talk about deep learning, we're talking about artificial neural networks. And this is very similar to how a human brain works. It's able to teach itself. And it's able to do this fairly accurately. It just needs a lot of data to do this. And so that's the disadvantage, is that it requires lots and lots and lots of data. And it also needs a powerful GPU to be able to think and go through all that data. So the key thing about this is it takes a long time to actually process. It takes a long time to learn. And this could be weeks, could potentially be months, depending on what you're getting it to do. So the key thing is it processes a lot of data, extreme amounts, and it goes into a lot of granular detail when it's doing that. So once it's learned, it's able to then give predictions extremely fast. Now, how, I guess, like deep learning works is that it's done through a neural network. So it means that we feed it lots of information, it's able to make predictions, and then it compares those predictions to the other predictions it's made. So essentially, it's going to give itself lots of information. It's going to go back and forth, and prioritize where it feels it's correct or where it's getting a better result. Because ultimately, what we'll do is we'll give it a goal. We'll say, here's all this data, here's the goal that we want. And what it'll do is it'll keep trying to get closer to the result that it's trying to get. And the key thing is, like, once it's done processing, it's going to give us the final result. But if we're looking at the input layer and the output layer, that's ultimately what we see. We've got all these hidden layers in there. And that's the problem, is that we don't ever get to see how it got to that result. We don't get to see how it made its decision. All of that is being done through the hidden layers. And that's how it's thinking. It's going through and it's assigning its own features, its own labels. It's teaching itself, and it's doing this on a very massive layer, but also very granular in terms of what it's looking for. So that's why it's always referred to as a black box, because we essentially get to just see what it outputs rather than getting to see what's going on underneath. And I guess if we were to summarize all this, it's extremely powerful, but it requires a lot of power. In other words, a lot of GPU. And at the same time, it gives complex results and an immense level of detail, but it's a lot slower for it to learn. And since we're learning at a much more complex level, it's a lot harder for it to understand also for us how it actually got to that point. So if we're trying to troubleshoot or wonder why it got a weird result, it's a lot harder to decipher how it actually got there. Now, in terms of machine learning and deep learning, I told you I'm trying to throw a lot in a little bit of time, but machine learning is where we're training it to through programming it on how it should learn. So it's fast to calculate. It's also able to process a lot of information very fast, but it doesn't require a lot of processing to do that. Whereas deep learning uses neural networks to teach itself. So it requires a lot more data, and it requires a lot more time to train. and it also requires a lot more resources, but it's able to do this at a much more complicated level. So it's able to calculate a lot more once it's trained at a much more greater detail. Now, just to jump around a little bit, I think that a lot of us get kind of thrown to the side when we think like, is AI going to take our jobs? Is it going to automate everything? And everything's just a click of a button at that point. I think the key thing to understand is that AI is basically a tool. It's something that's very powerful, is able to give it a goal and train it up to do certain things to get certain results. But I think it's better to look at all this like, if you're a lighting artist and radiosity and global illumination, all these new lighting models came into play, then we might think, oh my God, I'm going to be replaced. But if anything, it made our job easier. It made us have the freedom to do what we're doing and be able to have more freedom to be an artist rather than getting bogged down with the technical stuff. Same thing with particles. When fluids became more of a mainstream solution, it means that you might get really interesting results with fluids that you couldn't do with particles, but it just means, hey, here's some new tech that I've got to adapt. So if we start looking at these as really smart tools that are making our lives easier, we're not as threatened by them. So I think that ultimately it just means that it frees up our time, makes our life less complicated and bogged down. And I think it makes us really think of AI being something that, instead of looking at like what it could do, now finally we're at a point where we can see like what it can do. And this is how it's going to really change our lives. So finally, and I started my timer late, so I'm probably already at 10 minutes, but I'll just talk about a few applications here. So deep fakes is obviously a big one that deep learning's become famous for, but a lot of the time we've seen it with internet gags, and it's because we're giving really low amounts of information. But this is something that for feature film can be explored very extensively, and DD is doing a lot of great stuff with that, as well as with performance capture. That's just really amazing and impressive. So there's a lot of things that with deep learning we would be able to do that an animator couldn't do. We could rig all the bones and muscles we want, keyframe everything we want, phonemes, morph targets, everything we could do, but we'll never get the subtle motion and really articulated animation that we would from the performance capture that a lot of the deep learning can do, just because it's able to do it on a much more granular level. It's able to see and capture a lot more data. So same thing with image generation for matte paintings, for face generation. There's infinite possibilities there. Intelligent animation, as well as predictable fluids and physics, faster and much more complex simulations, as well as we're able to do like lower data sets and have it then take that and do a much more complicated sim on top of that. Roto becomes easier, faster, more accurate. We're able to do a lot more advanced keying through hair, as well as deal with more complex shots, relighting shots, things like that. So, I mean, there's so much you can do with AI once you train it to have different results or different applications we're running it through. And it's more about looking at this as a tool to utilize to be able to do your job easier and have more freedom to be able to be the artist rather than being the technical operator. And I guess I had one more slide, which was thank you. And feel free to email me or whatever if you have questions. Thanks, guys.